So, quick outline for what we're talking about today. I will start with the taxonomy architecture and our general scenario that we're going to be using as our excuse for coding, basically. And then we'll go through 3 different demos, one about importing, one about synchronization, and one about tagging. And then I'll try and leave some time at the end of the session for Q&A. The second 2 demos will use the client OM. So if you came to see a little bit of client OM code, you're in the right place. And let me just start with the scenarios. We'll get to the code in a minute. I'm going to run through this a little quickly. So the idea of the taxonomy was to have a single infrastructure that supports a large range of business needs throughout the enterprise. So you could imagine along the bottom of our graph here, we have level of control. On the left is the highly curated taxonomy, where there's a small group of people who control it. And on the right is the folksonomy, where anybody can create a tag, and it's basically a free-for-all. And then on the vertical axis, we have the scope. So there are things that are local to the current site, and then on the top you have things that are global to the entire enterprise or across multiple farms. And we have a number of different scenarios that we picked out when we were designing the taxonomy. For example, in the far right lower corner, you see my sites. So that's something that's very local and that is a folksonomy, where anybody can create stuff for their my site. And in the upper left, we have records management, would be a case that is very carefully managed by a small group of people, but it's global across many farms. My favorite scenario is in 2013, the managed navigation feature that allows you to define your navigation for your website using the taxonomy. So that is local because we have this new feature called pinning that basically allows you to bring in terms from other places, but still have it be locally controlled for your site. But in terms of level of control, it's not tightly managed. It's just the people who have designer permissions to do the navigation for the site. They're the ones who can edit it. And the term store is the central repository where all the taxonomy data is stored. So it's a separate database from the SharePoint Content DB. It has a web service that is used for the back end, and it's consumed through the service application infrastructure. So there's the term store. Within the term store, we have the groups, which are the security boundary. So when you set permissions for term sets, basically you set them on the group, and then all the term sets within that group have a set permissions, more or less. But this is also used as an organizational container. So if you have different groups of people that maybe have the same permissions, but you're trying to separate the term sets just for organizational purposes, you can use the group for that also. And then within the group, you have the term sets. We imagine a maximum of 1,000 many term sets per group. Right, 1,000 term sets within a single group. These are not like hard limits; they're just support limits. So if you put more than that many term sets, then we don't support it, but it probably will work. And then within the term sets, you have the terms. We have a maximum of 30,000 terms per term set, a maximum of 1 million terms within the whole term store. And I should just say a term is not just a word. It can include many different synonyms, translations. It has other data such as descriptions and their custom properties. Actually, in 2013, we've exposed the custom properties through the UI so people can informally just go and create extra data on the terms. So one term is not just one word. And just out of curiosity, is there anybody here who has any kind of application that's anywhere near 1 million terms? Okay, so I guess we set our limits pretty reasonably. And this is what the term store management tool looks like if you haven't seen it. You have your, at the top, the term store, and then this is a group, and then within that, we have a term set, and then within, you have the terms, and then you can right-click any of your operations. It's pretty straightforward. One thing I'll call out is in 2013, there's some new tabs there for managed navigation and the search features, so you might check those out. And a little more block diagram stuff. So the management of the term store happens in central admin. That's where you create the service application, which creates the database. It's also where you configure your connections to other farms. The taxonomy groups are done through the term store management tool, as is everything else. And I already talked about that. And then the term sets, create and manage different hierarchies. This is kind of boring. Let's get to the code. Okay. And one thing I'll point out on this slide, though, is that most of the operations you do are on the terms themselves. They're the really interesting thing in taxonomy. You can deprecate them. You can mark them as not available for tagging. You can translate them. You can reuse them. In 2013, you can pin them. So that's the main focus. Okay, and I'll give you one more diagram just because this is classified as an IT pro session. So you might have a multi-farm enterprise. Let's say, for example, you have an HR system in one farm, and then you have your corporate taxonomy in another farm, and then you have something local, but we have, say, 2 web applications on our local farm. And then we have term stores in the different web applications. And then we have a site collection with a document library that has multiple columns in SharePoint. And we could have 3 different columns that are 3 different managed metadata columns, and they can each be consuming term sets from different term stores coming from different farms, and it will all come into one place, and you can use them all simultaneously. So beyond being just a way to create hierarchies and store them, the taxonomy has a vision to be really scalable to really large scenarios, although most aren't this complex. Okay, let's talk about coding. So in my scenario, we're going to be consuming an external taxonomy from within SharePoint. So you can imagine that, say, the HR department has an authoritative hierarchy of different company divisions and subsidiaries, and their system is not SharePoint. We can hope it's some other Microsoft product. And we want to classify our documents in SharePoint using the HR's designations. So how do we get this data into SharePoint? This would be the starting point for somebody who wants to interoperate or import data into the taxonomy. So the first option would be just to start typing. It sounds kind of funny, but you could open up Term Store Manager and just start creating terms. And if you actually had maybe 20 terms, that would probably be faster than any of the other options available to you. The more likely thing that you would want to do is have some kind of help, like if you had a lot of terms. So we do have a feature for importing. If you go to, sorry, one slide about that. It's cheap and easy, good to get you started. All right, keep going. Term Store Management Tool. So you go to Term Store Management Tool, and there's a link there. If you click on the Manage Metadata Service, that's the default name of the term store. Basically, this will export a CSV file that you can edit in Excel and then import it back. Many people don't actually know about this feature. But this is what it looks like. And we actually found a way to represent a hierarchy within Excel. And you can specify some things like the term description. You can see available for tagging as a column in there. But it's somewhat limited. And this is how you import it. You go click on the group and then do import term set, and it will read back the CSV file and create you a new term set. So the problems with this are it doesn't support synonyms, it doesn't support translations, it doesn't let you set custom properties, and it can't do any of the more complicated topologies such as pinning and reuse terms. And just out of curiosity, how many people knew about this feature? Okay, then I'll speed it up. So what would we do in that case? Our 2 guys are here, and they tried the CSV file, but they don't, they can't specify their custom properties. Start coding. That's my favorite option. So code sample number 1. The design that I'm using will be to have an XML file that's hierarchical and a little more structured than CSV, and I'm going to read it and create the objects in the term store. And this is kind of, for the demo purposes, this is kind of expedient because I don't have to get into the HR system and talk about some other system's API. But it's also actually a pretty good approach because if you imagine, for one thing, if you had, say, 10 different systems, or maybe not 10 systems, but 10 different versions of a smaller set of systems, and you actually wanted to export and import hierarchies between all of them, that would be like n times n minus 1 divided by 2, but then times 2, because you're going in both directions. That's like 90 different import tools that you have to write. Whereas if you have one central format, say an XML, you only would have to do 20 of them. So you basically go to and from XML for each one. And it also has the benefit that you can compare the XML documents with a diffing tool, and you can sort of track them and save them. So it's a pretty good approach. So this is the XML file I designed. It's not a standard. It's just sort of a straightforward thing that I created. But you have, and just I'll highlight here, because we have a lot of kind of code, I've put a progress bar at the bottom of each of my demos so you can see how far we are through the code. Okay. So the term set tag basically specifies the name and the group. I could have made the group a tag, but I didn't for simplicity. And then you have a term, and I've specified a name and the GUID, and then a description and some labels. And then down here, I have the deprecated flag. So that's a slightly more advanced thing. You can specify if you want your term to be deprecated. That means that it's still there, but we're discouraging people from using it. It's not active right now. So this is pretty minimal, but it's also, if you were building your own tool, this is quite a lot of functionality that we have to start with. And you can imagine adding other properties to the file format pretty easily. So I import it using the XML serializer. So I've defined C# classes that have the word goal in them. So it's the goal of what we want to be in the taxonomy, so I don't confuse my class names with the taxonomy OM. So I have a term set goal on the left, and then a term goal on the right. And they have an ID, a name, and then a list of child objects, and then some extra data like being deprecated or the description or the labels. And you'll note that actually these two classes have some stuff in common. So the term set has a name and ID just like the term does, and it also has a list of child objects. So I've taken that out into an abstract base class in my code sample. Oh, and one other thing I'll say is you don't need to be furiously taking notes or screenshots right now. Last year what I did is I put all the code in the PowerPoint slides as a way to kind of distribute it, but this year I've actually gotten permission to release all of my code samples. So I will post them on the ECM blog after the conference, and you'll be able to download them. And I'll give a URL for that at the end of the session. So, yeah. And that also helps, because I can go through it faster, because what we are doing now is more of a tour of what you'll get to enjoy in Visual Studio on your own time, rather than actually having to go and remember every detail that's happening here. OK, so let's keep going. And one other thing I'll point out about this abstraction that I created is that the taxonomy OM has a similar concept. It has a term set item, which is the abstract base class for its term set and term class. OK, so we'll start the program. So I haven't made this super robust. I haven't put in a lot of error handling. I'm not using command line arguments because I want to actually be able to go through all the lines of code in the session today. So if the slides seem a little not best practices for coding, it's just because I want to be able to squeeze everything onto the slides and let you look at it. And we'll at least be able to do that for the first two demos. The third one, if we start running out of time, I may have to race through it. So the first thing in the main program is to load the XML. And I'm just using the XML serializer here. I won't go into a lot of detail about that. It's pretty standard. And then I have some code that checks to see if I typed in the GUID more than once, used the same GUID more than once, because I made that mistake a few times and it messed me up. And I'm using this enumerate tree depth first method that I'll talk about in a minute, but it's just sort of an aside. And then here's where I create my SP site. And then I create my taxonomy session, which is the way you interact with the taxonomy. And then I set update cache to true. This is a parameter that causes the taxonomy cache to fetch any recent changes right away. So it causes a WCF round trip, which you would want to do this before any editing operations because it reduces the chances of a save conflict, but you wouldn't want to do it in general because it causes a performance problem. And then there's the term store. I'm just going to use the default term store, but you could use other term stores. There's a collection of them. And I'm also going to save the working. So the working language is the way that you normally specify which language you're using. So if you go to term.name, for example, the language will change according to this global variable that sets the context for all the operations you're doing. But a few of the methods actually require an elseid, so I'm just going to save it in a variable here. And then import term set is the main function for this demo. So, and this was the enumerate tree depth first method that I mentioned. It's just kind of an abstract way to iterate through stuff. You might want to look at it on your own time, but it's kind of cool. OK, so import term set. So we have one section of code that goes through the groups in the term store. And I search for one with the name matching the XML that I read. And I have, again, this term set goal class that is the thing that I deserialized from the XML. And if it doesn't exist, then I create it. And then for the term set, I call get term set based on the ID to see if there's a term set existing. And if it does exist, I delete it, which lets me run my demo more than once. And then I have another call to create the term set. And this is pretty simple, straightforward stuff. The more interesting thing is this next slide, which is the import term slide, which is recursive. So we come into and you can see the parameters. There's parent item and parent item goal. So I'm using the abstraction there because I want to start with the term set and then treat it the same way that I treat the terms, as something that has a collection of child terms. So I just go through and call create term. Basically, for each XML element, I create a corresponding taxonomy element. I set the name. I set the labels by calling create label. And here's a case where I have to use the elseid, and then the description, and then deprecated, and then I recurse. And that's pretty much it, actually. So yay, demo time. But just to pause for a moment, this was a little dense. But we've actually managed to do something that's kind of significant with a small amount of code. So let's switch over to the demo machine, and I'll run it. So here I am, just to prove that this is a real project. I'm going to build it. And then I will go over to my DOS prompt here and run term set import. And we had a lot of network connectivity issues at this conference. So I'm actually running SharePoint on my laptop, just so I don't have any problems. I don't need any internet at all. And interesting point, this is actually an older laptop with only 8 gigs of memory on it. So I installed Windows 8 Server, and I'm running SQL Server and Visual Studio and SharePoint and the App Fabric server on here. The only thing I'm not running is the search server, and it actually is pretty snappy. So that's, in my opinion, a real testimony to the new Windows operating system. And here we are in the term store management tool. We have the company, oh, and let me show you the XML file itself. So this is the file that we had in the slide there, but company divisions, development, engineering, test, and then in the term store management tool, there's the result. So yay, okay. So that's what it's like to go through a code sample with Pete. Is everybody kind of okay? Are we like all on the same page here? Anybody having trouble following it? Dan? Dan's the taxonomy PM, so he definitely shouldn't be able to say that. Okay. So we're going to kick it up a notch here. Let me switch over here. Okay, so we're back to my 2 guys here. Staying in sync. So we're up and running, but what happens when the HR department makes a change to their hierarchy? They could add terms, they could modify them, they could delete them, or they could move them somewhere else in the tree. So what do we do in that case? Can we simply delete the term set and then run the tool again to import the new data? Yes, we can. All right, I guess we're done. We can go home. But there are some problems with that. So one problem is that there's no way to merge your changes. So for example, if somebody had created custom properties or put some extra data on there, if you're just going to delete the term set, you lose all that information. And in particular, with reused terms, you lose more than just one term. You lose the connection and relationship with the other terms. There's also a potential downtime. Like if you imagine a keywords term set that could have 20,000 terms in the term set. We actually have something like this at Microsoft. The amount of time it would take to go through and delete all of those and then recreate them would actually have your taxonomy in an unusable state for half an hour optimistically, which might be bad. And then the last thing I'll point out, it's kind of a technical issue, but there are timer jobs and other things that monitor events that happen in the taxonomy. So when you go and do a huge operation that's changing tons of different terms, all of those things have to wake up and do something. And actually, if you make enough changes, you can actually wipe out the history. Like it only keeps a window of so many events that have happened recently. And if you wipe out too many things, then instead of just waking up and having to process those changes, some things will have to actually start over and do a whole batch of changes. So if you're programming against the taxonomy, there are some disadvantages to just deleting a huge thing and recreating it. So that brings us to our second code sample. So we're still starting with XML, but in this case, the idea is that we're going to take a look at what's in the XML and what's in the term store, and then we're going to update the term store. So in my kind of programmer diagram that I made here using PowerPoint, I'm showing that we're adding a term and deleting a term, but we're leaving the other ones where they were. And before we get into that, I'm also going to be using the client OM for this demo, and I just wanted to talk about that briefly. So the SharePoint client object model is kind of an interesting and unique way of doing remote client operations. So if you imagine a spectrum of different kinds of technologies, on the far left you might have RPC, which feels like an API. Basically, you're interacting with objects, but every time you touch something, it causes packets and network transmissions to occur. And it's stateful, which means that being like an API, when you assign properties on something, it kind of remembers the properties, and they sort of act like objects. Whereas web services are a totally different approach. There are specialized protocols that are optimized for doing certain operations with a lot of thought put into how many round trips you do, and it's very obvious when you're using web services that these are network transactions that you're doing. It doesn't feel like an API. And they tend to be stateless. Like the whole philosophy of REST is there's an input and there's an output, and that's your transaction. So the client OM kind of falls in the middle. It's modeled after the server OM, and in fact, our documentation for it is based off of the server OM documentation. So it's more, sometimes the classes have different names. It'll be web instead of SP web, but it follows very closely the way the server OM is designed. But it supports things like batching via link queries, so you can actually queue up a whole bunch of operations that are almost like a small script that you upload to the server that runs remotely. So that actually solves some of the problems that RPC had. And it even has try-catch blocks. Many people don't know about this, but in the term store manager, for example, we use the client OM. So when you go and make changes in like 5 different boxes and hit save, it will actually perform all the changes, but has try-catch blocks around each of the assignment operations. So if any of them fail, we know exactly which ones failed and what the errors were, and it can do all that in one round trip. You definitely cannot do that with REST. Another interesting thing is it has many different variations. So there's client OM in JavaScript, which internally is based off of script sharp. And then there's the managed client OM, which is basically the C# version. Then there's one for Silverlight and phone. And then most recently, there's a REST version of it in 2013. So all of the other ones require some kind of local API that you get from Microsoft. But the REST one, you can use any standard REST tool. So that's kind of exciting, although I'll just say it's not supported in the taxonomy right now. But it is supported in a lot of the other parts of SharePoint. OK, so back to our demo. So I have actually coded, like the second and third demos, I've actually coded them both for server OM and client OM. Today, we're only going to really talk about the client OM versions. But in the code sample, I'm actually going to give you all 5 of the demos that I made, so you can look at them. It's really interesting, actually, to look at the difference between server OM and client OM. And part of the reason I'm rushing a little bit versus last year's version of this session is because the client OM is more verbose. So you have to do some extra coding for managing the different objects. And my slide deck actually got bigger. Like my code got bigger by like 30%, but so did my slide deck. So, OK. So you use a different, you're probably familiar, you use a different namespace, SharePoint.client.taxonomy instead of SharePoint.taxonomy. So the code this is the code for reading the XML file, so that's definitely going to be the same. But a lot of the code does sort of look the same. This is how you actually, whereas in the server OM, you create an SP site object, and that's your way of interacting with the SharePoint database. In the client OM, you create a client context. And then in the server OM, you create a new taxonomy session using a constructor, whereas in the client OM, we call a static method and pass in the client context. So the syntax is a little different. Like on the server OM, you set update cache to true. On the client OM, it's a method. The reason for that is because there are these transactions. So with the client OM, you do a series of operations, then you call execute query, and it will basically play back the script of all the stuff you've done up until that point. So with update cache, you need to call that again at the beginning of each of your batch of operations. So it can't just be a parameter to the constructor. And then the terms, in this case, the default site collection term store is a property in the server OM, but it's a method in the client OM. And then we're not doing that here, but the last thing I'll point out is the sync term set in the server OM was just one method, whereas in the client OM, I actually had to split it apart into 2 just to get the code to fit on the PowerPoint slides. But that's also sort of a sign that we're doing more bookkeeping in the client OM. OK, so from here on out, it's going to be pure client OM. So I'm going to, again, race through this part of it a little bit, because it's not that interesting algorithmically. But it does show you some illustrations of all the different things you do in the client OM. So here I am loading properties, and I use these link expressions to specify that I'm loading the term store and the working language for the term store. And then I'm loading the collection of groups. And then for each group, I'm going to load the ID and the name. So it's almost like a database query where I'm building up nested things that I'm querying. And here's an example of how you call a method. So I'm calling getTermSet, which, as I mentioned before, no actual work happens when you call this. Like if you look at there's a tool called Fiddler that this guy Eric Lawrence at Microsoft made, and it lets you actually see the network communications with the web browser, but also for client OM, you can see the command that's sent and the response that comes back. I highly recommend using it because it's basically the commands going to the server are XML, and you can browse that with Fiddler, and then the responses that come back are JSON, and it has a nice diagram of that. So you can actually see the guts of this command that comes out of the C# code, and it gives you a lot of insight into what's really happening. But anyway, so if you call getTermSet here, all it's saying is we're going to do that when we execute query. So what would happen, for example, if it returned null? Like this variable termSet is either null or it's not. It can't, like, there's not a way that the .NET framework can come and change it later when we call execute query. So actually, even though on the server side, get term set can always return, it can possibly return null, and the client OM, it will always return an object. It just has a property on it, which you can see over on the right there, called server object is null. That is the thing that will get filled in later during the query. So when you're checking things to see if they're null, there's a different way to do that in client OM. That's kind of my point here. And then I load the stuff. So the properties of the term set, I load them in the same way that I loaded the other objects. So I'm saying if something happened to come back, then go and get me these properties at the same time while you're at it. And then here we are with the first call to execute query. And I've really called these out in the code. I actually made a simple static function that prints out a message saying I'm calling execute query and then does it. That's all that happens in here. But it's you think about it a lot when you're coding because it has a big impact on your latency, like round trips, and it also can affect the transaction states. So for example, if your operation is taking 5 or 10 minutes because you're going through a lot of different things, somebody could come along and change something behind your back. Okay, and then here's kind of another example. I've actually requested all the other groups, but I now want to go and find the one that has a certain name. So here I'm doing something on the client side. So I insert a call to toList, which is a link function that will basically copy the groups into a C# list object. If I hadn't done that, then my first or default call here would actually be queuing up another command to run on the server rather than running on the client. So there's actually, it's a little tricky when you first start working with this because you really get to learn the C# link features really fast. And here, when I check group equals null, I'm actually comparing against null because this is an operation that happened on the client side, not on the server side. And we talked about this one already. The idea of this code is just we're going to create the term set if it didn't already exist. Okay. I guess I spent a little more time on that than I meant, but we're actually doing okay with time here. Okay, so load the tree of terms as a flat list. I guess I should talk about that. The one thing that the client OM doesn't do very well is hierarchies of things. So you can certainly say, get me A, and then if it has things of type B that are children, get me those, and then C. But if you wanted to go like an arbitrary number of levels, say just keep going down the terms until we get to the bottom of the tree and get me everything, there isn't actually an easy way to do that in the client OM. You, sort of in your query, you would have to actually say code for every single level that you want to query. So my approach here is to call getAllTerms, which returns everything in a single flat list. And on the server side, it's actually more efficient to do this anyway because it will cause the entire batch of terms to be loaded at once rather than doing separate SQL round trips to get each term. So this is kind of a good technique. You'll see this technique even in the server version of the demo. And then I'm going to load the properties of my terms. But because you commonly fetch the same things in the client OM, so like every time that I get a term, I pretty much want to get the name and the ID and these other important properties of it. What I've done is actually taken that part of the link expression and put it into a global variable that I use in more than one place. This is, again, something you might want to use in your own code. And then, so my second WCF call, the first one was creating the term set in the group if they didn't already exist and finding them and getting their properties. So now my second WCF call is going to get the entire set of terms that are in the term set right now. Because if you remember, we're trying to sync it to match what's in the XML file, so I need to know what's on the server first before I start creating things. Okay, next, and we're on block 3 down here, so I apologize if this is a kind of a lot of code, but it's what we're here for. I'm excited about code. I like code. Okay. So this, I'll sort of skip over this a little bit, but I'll explain it at a high level. So we read the terms in a flat list, but we want to use them as if they're a tree. So I have a wrapper class that I created that has the term, which I'm using the abstract base class because I also represent the term set this way, but it's the item there. And then I have the GUID of it, and then its parent ID, and then a collection of its child terms. So I'm going to sort of, from the flat list of things I got, I'm going to build up a nice hierarchical tree that I can interact with as a tree, but with the efficiency of reading it as a list. So that's sort of the idea of this wrapper. Everywhere you see wrapper, really what it is just a term, except in one case where it's the term set. Okay, and then here I am hooking up. Once I put everything into the tree, then I go and hook up the parent pointers for them. This is just data structure stuff. The next thing that's more interesting is an algorithm question. So what we're doing is incrementally syncing from an XML document to the term store. So that's actually more challenging than just importing something and creating it. For example, in the taxonomy, there's a constraint that says you can't have two terms side by side that have the same name. So this could arise temporarily. For example, if while we're syncing, like on the HR system, they had deleted a term, and then for some reason they had created a new term at the same level that has the same name, but it has a different ID and different properties, because, say, it's been several months since we synced with them last. So if that happened, when we're doing our operation, we need to delete. It seems like we need to delete the term first and then create the new term so that we never get into this temporary state where there are two terms that look like they're conflicting with each other. However, there's another case that I have a diagram to help you envision. So suppose that in our company divisions, they had actually deleted 3 of the terms. So we have development, engineering, and hardware devices got deleted, but test, which is one of the child terms, got moved out. So in this case, we don't want to, if we delete development, it's going to delete all of its children in the taxonomy. So we don't actually want to accidentally delete test. So this is a reason why it would seem like we should really move things around first and then delete them second. So how are we actually going to handle that? Kind of an algorithms problem. So I have a 3-step method that I came up with that will correctly handle every possible case that you can encounter. 1, 2, 3. So the first step is to do the adds and moves. So we move things around and add the missing things to sort of get stuff into the right place. But there's a problem if, like I said, you have 2 things at the same level. So what I do is I temporarily rename one of them. Then the second step is to go through and do the delete operations, where we delete anything extra that's left over in the term set. And then the third operation is the updates, where we go in and set all the properties of the terms to the right thing. And in the process, we will set the name to the right thing, which if we had introduced a temporary name, that will actually put the name back to being the right thing. So this is kind of the right order to do things. And because this is client OM, we have to squeeze in an extra query in between 2 and 3, because there are certain things that can't be queried as a property, like the description. When you read it, you have to pass in the locale ID. So that's a method, so we need to actually call that for each of the individual objects. And this is another benefit of having the wrapper, is it's a place where I can store the client result from calling get description. And just to point out, just to show that this is a real interesting algorithm, we actually implemented this in SharePoint 2013. When you click Edit Links, what you're doing is in the JSON, you are dragging and dropping things around and renaming them. And then when you click Save, it has to sync up the taxonomy to match whatever you did in the browser. And I coded that, so that's part of why I'm so interested in this. OK, thank you very much. OK. So this is real stuff. It's not just academic. OK, so adds, moves, then deletes, then updates. This is what adds and moves looks like. It's a recursive method that is going through the XML, and at each level, it is looking at the item in the XML and says, does the term already exist? And remember, I had called it term goal. So again, it's sort of this idea that we're trying to get to a certain goal state where the taxonomy matches what was in the XML. So if it does not exist, then we create the missing term. And you see I have a method there, generate name without sibling conflicts. So this is a loop that goes through and checks all the siblings to make sure nothing has the same name. And if it does, in this demo, I'm just adding a GUID to the end of it, which will pretty much make it unique. In an actual real implementation, it's only statistically unique. So you probably would want to use a counter or something that really is unique and more deterministic. And then I also have to update my data structure. So for the wrappers, when I'm adding things, basically I have to update the local picture of them so that there's a wrapper that matches the new thing that we added, so more data structure stuff. And then if the case is that it already does exist there, so we don't need to create it, but we found it, we need to check to make sure that it's in the right place. So there's another case that will move it to the right place if it's not in the right place. And this, again, also needs to check for naming conflicts. So if we move some term to some other place in the tree, but there happens to be something there that hasn't been deleted or moved away yet that has the same name, we introduce a temporary name to avoid a conflict there. And this is the kind of stuff that comes out in testing. The first time I coded this, I was like, I got it done, yay. And then I started moving things around, and I got these weird errors. And it didn't happen right away. It took us a while to actually find out that you can have these cases. OK, I'm not going to talk about this in too much depth. Yeah, update the data structure, blah, 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 recurse. OK, deletes. So deletes are really simple. All you do is go through the terms, and here we are iterating through the wrappers again. So we're, in this case, going through the tree of stuff that represents what's in SharePoint right now, and then we're checking to see if it exists in the XML, and if it doesn't, then we delete it and recurse. And then the last one is updates, which is the most code, but conceptually it's the simplest, because all you do is go through, and for each item you compare it to the XML, and if the name's not the same, then you change the name. If the labels are not the same, you change them, although the labels are a collection of things. So I'm actually using the hash set in C# here, so I do set operations. So I say labels and labels goal. So one of them is a set of strings that are my goal of what I want to be there, and the other one is a set of strings or what are there right now. So I do labels.accept labels goal. So this is saying go through anything that exists in SharePoint but does not exist in the XML, and we need to delete those. And then I do the reverse case, labels goal.accept labels. So something that is not in SharePoint but it is in the XML, then we need to create the label. So, and I think C# has really come a long way. Like, this kind of stuff wasn't in the first version of it, but we're doing some rather complicated stuff here. It's behind the scenes actually a hash table for efficient string comparisons and stuff, but it's not a whole lot of code if you consider what it's doing. This is sort of the dream of people in the 1990s when they were drawing their algorithms on the board and imagining that people would really code them. The description. For deprecated, there's a function that you call term.deprecate. So we just set it to true or false to say whether we want it to be deprecated, and then recurse. So I really appreciate your patience. We are ready for the next demo. Let's see what it looks like when it's running. So this might be the most boring one to talk about, but it's actually the most fun one to run because it's sort of like a little AI. So I'm going to, this is my XML file that we had before, company divisions, development, engineering, hardware, devices, test. I'm going to build the solution. Here's the C# code, again, just to show that I'm not cheating. And it's a total of 430 lines of code. So give yourselves a hand for going through that much code. And let's see, term set sync. So I'm going to run it. And the first time around, it doesn't do anything except verify stuff because we're using the same input that we used before. So now I'm going to grab another XML file that I prepared and paste it in. So what I did is I moved test under engineering, and then I cleared the is deprecated flag. So let's go to the term store management tool and just sort of see. So right now we have development, engineering, hardware, devices, test. So I'm going to run it. So it tells us it needs to move test to be a child of engineering. And then later it finds out that it needs to mark hardware devices as not deprecated. And let's see if it did that. So test is now under engineering, and hardware devices is not deprecated. There's more. Let's try example number 3. So here I'm going to delete engineering, and then I'm going to move test back under development. So you can imagine there's quite a lot of reorganization going on in this poor department. And here it is moving test to be a child of development again, and then it's deleting the term engineering. Let's see if it got deleted. Yep. Okay. Yeah. I won't make you clap for each run of the tool. But the last one is actually the most challenging. So in this case, we're going to put it back to where we started. But I'm going to change the GUID for the development term, which was the root of the tree. So in the taxonomy, you can't change the GUID because it's sort of the database key of an object. So the only way to change the GUID is to delete development and then create a new term with the different GUID. So for the algorithm, this is like a big nightmare because all the things underneath it need to be moved out, and then we need to create the new one and then move them all back in. And you can imagine an employee actually having to do this in the term store manager if our enterprise encountered that problem. So let's see how the tool handles it. Okay, so let me expand this. So we're going to create the missing term development. And note that we're doing that before we actually delete the old development. And then we detected a sibling conflict, so we're going to rename it temporarily. And then we're going to create the missing term engineering that we deleted in the last one. Then we're going to move some stuff around, move test. And then we need to delete the term development that had the wrong GUID on it. And then Now when we go to do the updates, we have to go and rename development back because it had a temporary name. And we have to add its labels and update its description and do a bunch of stuff. And let's go to Term Store Manager. Yay! So that's a pretty complicated algorithm to show on stage in PowerPoint. Okay. It will fix that too. So have fun playing with my sample code when I post it. You can don't file bugs against me. Okay, so applying tags to documents. We're back to our guys, and we've imported the taxonomy. But what's the point of all this? What's the point of having terms in the term store if you don't go and actually apply them to a document? And in SharePoint, it's a little obscure. The idea is that you have managed metadata columns that are bound to a term set, and then you're going to assign a term to them. And that's what we mean when we say tagging. Like, it sounds like you just go and tag something, but you have to actually tag a specific kind of term from a certain term set to a specific column. And if you had 3 different managed metadata columns, those are 3 different kinds of tagging that are happening on one document. Anyway, so how would we automate that? And I'll let you read my, so more code. Okay, so in this demo, we have an Excel spreadsheet which has the data from the HR system. Again, it's a little, synthetic or not super realistic, but I don't want to get into the API of some other system. So we're just going to say, okay, let's say that it's in a CSV file, and that's where we're going to get the data from. But we're going to put it into SharePoint and basically match up the Excel information with the terms from the term store and use that to tag the documents. So here's what my XML input file looks like. CSV input file. I've kind of formatted it nicely in Excel, but basically it's just plain old text file. And in one column, we have the names of the documents that we want to tag. And then in the other columns, I'm only going to show one column today, but this code sample will actually support an arbitrary number of columns. You can just specify them in Excel. So you could have, for example, your HR department managed metadata field, and then you could have your geographical location managed metadata field, and you would specify them in here, and the code will loop through and assign them at the same time. And then there's a column for the tag that is just, in this demo, we're just going to go find the thing with that name in English in the term store. It could also be a GUID. There are other ways you could look it up, but we'll keep it simple. Okay. So back to the code, and unfortunately back to the first progress bar box there. Okay. So I'm getting my list. This is the first time we interact with something that's not really a SharePoint taxonomy object. We're now into the core CSOM, so lists and webs and so forth. So I'm going to get my documents library, the list, and then I have a query here that's going to go and get the fields that we have. Let me see. And then from that, I'm going to pull out the taxonomy fields. So up here, let me talk about this for a minute. So, because I think this is the first point where we used load query, which is different from load. So the idea of load is you have some object and you're just telling the CSOM, the client OM, what properties you want to load. With load query, it's more like you have a collection of things, and then you're telling it to go through, and there's that include thing where you can say, well, for each of them, this is what I want to include, but I can also put in a where clause. So here I'm saying, go through the list of fields for the documents library, but just get me the taxonomy fields and leave out everything else. And so that filtering will actually happen on the server side. But the objects that I get back will still be of the SharePoint type field. So here I'm going to cast them all to being taxonomy field. And then I'm also calling toList that will take this enumerable collection and make it into a nice C# list. So that whole little round of things is going to get me a list of the taxonomy fields for the library. And it's not highlighted here, but I did call execute query. So at this point, I have the real objects. Then for each of the fields, I'm going to go through and load more stuff. And then import template is the main starting point of stuff. And before we get into the actual importing, I'll just mention some of the other data structures I'm using. So when I read the stuff from the Excel CSV file, I have a class that represents the items that I'm reading, and I have some code that reads that. And then I guess I should call out, it has, in Excel, if you remember, there's a column that has the internal name of the taxonomy field, and then I have the GUID of it. So this is just data structure stuff. And then for the term set, I need to be able to rapidly go through and grab terms with different names. So for example, when I see, like let's imagine the CSV file had thousands of rows in it. When I see like development, I need to go find that term in the term set. So I don't rely on the taxonomy OM for that. I build my own C# dictionary that just lets me look up terms by their name. And I use ordinal ignore case because the taxonomy names are case insensitive. And this, I'll skip over that. It's not that interesting. So, and then when I read it, I won't go into how I read the CSV file in too much depth, except that I do use a regular expression. And I looked around on the web to find a regular expression for breaking apart a line from a CSV file. And all these sloppy people were writing regular expressions that don't think about, well, what happens if you put something, like a comma in your field, then you need quotes around it. Okay, so we need to like check for quotes. But then what would happen if you put a quote in the field? Then you need to have a double quote, and there's like some special cases, and I couldn't find a single person who had made a regular expression that correctly handled them all. So I made my own rather large regular expression that you're free to use this in your own applications. Yay. But this does handle every possible case. Okay. And then get term sets by internal name. Do I want to talk about this? I'll just say this is going through, and for each of the taxonomy fields, it's going to go find the corresponding term set and load it so that we have it handy. And it's going to put it into that term set lookup class so that we can look up terms from it. I'm not going to talk about the code in too much depth. Because import template is the real centerpiece of this demo. So this is me calling that slide that we just skipped. And then here is the part that reads the Excel stuff from the CSV file. And then this is the interesting thing. So process list items. The idea here is that we have a delegate that does something to one list item, and then I have a method that's going to go and run that delegate on every list item. And the reason for this formalism is that when you have like thousands and thousands of rows, in SharePoint, you can't just go and fetch them one by one. You need to have some kind of mechanism that kind of efficiently pumps through them. And you can do that in both the client OM and the server OM, and the techniques are a little different. But first, let's talk about the delegate. So this is the thing that is processed on each row. So what I do is I go and find the corresponding Excel row that matches the SharePoint list item. If it doesn't exist, then I'm just going to skip over it. In other words, maybe somebody added some new documents to this library after we had created our CSV file. We don't care about that. We're not going to put any tags on them. And then for each of the columns, so these are like the different taxonomy fields, we're going to go through and set the value on it. And this is basically, I only want to change the value. I don't only want to assign a new value if it has changed from the old value, because that makes less work for the client OM. It's kind of a common pattern. And this is the main thing. So if you're out there looking for how do I actually tag a document, it's surprisingly not that easy to find the answer. This is the line of code that you're looking for, the taxonomy field.set field value by value. So just to sort of summarize that, so let's say I just wanted to write some program and all it's going to do is tag one document with one term. You need to get the taxonomy field and typecast it to being, instead of just a SharePoint field, to being a taxonomy field so that you can call this method on it and give it the taxonomy field value, which is the thing that specifies the term. And it's generally, you just give it the GUID of the term. So it's a little contorted, but this is how you do it. And it's not entirely our fault that it's this complicated. Like the base SharePoint product really wasn't anticipating taxonomy when they designed it. So I'm generally reserve those comments, but here I feel like I'm compelled to say it. Okay. And then you call, anybody who's used the base OM knows that you have to call update on the list item after you make a change in order for it to actually be saved. But because this is client OM, you also need to call execute query to actually send all these commands to the server to run. Okay, and then the last thing I do here is check to see if we missed anything. So what would happen if somebody had a row in the Excel document that we can't actually find the corresponding SharePoint document, then I print out some kind of message so that you know that nothing happened. And this is probably a good thing that somebody would want in their real tool, but it was also really helpful to me because it was infuriating when I would like spell something wrong and then couldn't find my changes and couldn't figure out what's going on. So, okay. All right, so the last thing that I really want to talk about in this demo is that engine that goes through and processes a lot of things. So like we saw, it's called process list items, and it gets a C# action, which really is just a fancy like .NET 4.0 way of specifying a delegate that does something on a list item and doesn't return any results. And in the server OM, I'll just point out that there's a similar concept, but it's called the content iterator. So in that case, rather than you having to write your own processing engine, we've actually provided one for you. And behind the scenes, all it does is create the camel query and go through and fetch batches of items and then call your delegate on each of the items. So if you were doing this in server OM, I'm just going to show you on the slide what the corresponding code would look like. But like I said, I did actually give you a fully complete demo that does this whole thing using the content iterator on the server OM. Just not going to show it today, but you'll get it. OK, so here's the camel query that I'm going to use. So because I'm building this myself, I have to actually make a camel query, but we did give you a helper function called createAllItems query. So rather than having to actually put in the camel code, the most common thing that you want to do is just give me everything in the list. So we have a method that does that. And then once again, I need the list of things that I'm going to retrieve. Right, OK. So you remember in the earlier slide, I had that global variable that was a list of all the different link expressions because I used them more than once. In this case, because people can put different numbers of columns in the Excel spreadsheet, I actually have to build that in code. So here I'm actually going through and creating C# expressions and adding them to a list. And I'm kind of like starting to manipulate these expressions really as data objects rather than just code. And this is kind of the beauty of LINQ, that you can still specify this as a nice little lambda expression, but behind the scenes, the compiler will actually convert it into a tree of objects that are of type expression that represent what's going on here. So you'll be learning a lot about LINQ if you're using client OM in C#. Just since we have some time, I'll mention that in JavaScript, there's no LINQ at all. Instead, what you do is you specify stuff as text strings, and then there's some, you can't do quite all the operations that you can in C#, but it actually has something that will parse the text strings and build up the operations in sort of the same way. OK, and then this is the whole point of making this function here, is the batching. So I have a list item collection position, which is a class that sort of tracks where you are in the list. And so as I'm going through my for loop, I will get some items. I think I specified on the other side there 5, so I'm going to get 5 items at a time and then process them, and then I'll go get another 5. And so if you were watching in Fiddler, you would see for each 5 list items, we do a query that fetches them, and then they will come back in the response. And like you could say, well, why can't I just fetch everything all in one call? Well, if you had thousands and thousands of documents, you'll actually exceed the WCF timeout, and the server won't be able to query that much information and send it over the wire, and it actually won't work at all. It's not just that it would be slow. OK. Blah, blah, blah. Load some more stuff. Call the delegate. Count the number of things so we can print out a cool log message. Blah, blah, blah. Let's get to the demo. OK. All right. So last demo. Here's what the CSV file looks like. You don't have to make it yourself. There's in the program, there's like an if-def. So if false, then we're going to import. If true, then we're going to export. So basically what I do is I will export a CSV template, and then you open it up in Excel. So this is what exported in the earlier run of the tool. And then I'm actually going to go over here and open it. I don't like editing without all my cool columns and sorting and stuff. So here I'm going to make these bold, and then let's see. I'm going to sort them. By file name. And then I'm going to go, so division is the taxonomy field that the tool detected, and it sort of filled it out for me. If I had other managed metadata fields, they would just appear along the side here. And then I'm going to go in, and let me just make sure I get the names right, because we haven't looked at this in a while, but our divisions are development, engineering, hardware devices, and test. So I'll go in here, and let's put like test, development, what was it, hardware engineering? Hardware devices. OK, just put some example stuff in there. And I don't know if you guys have used flash fill, but if you ever find yourself actually manipulating data in Excel, it's really cool. If we had some kind of pattern here, like the items that have the word dev in them, or if they happen to end with an exclamation mark, or some kind of thing that would be a simple regular expression or little script that you would write, but some kind of rule where if those properties are true, then it's development. If these other things are true, then it's test. You can actually give it a few examples in Excel, and then you go and click the button for flash fill, and it will guess the rule and fill them all in. And it's a really advanced algorithm, and if it guesses wrong, you can correct it, and then it will learn and correct them. So if you haven't tried this feature before, it's definitely my favorite feature in Office 2013. Okay, so a little plug for the Excel team. Okay, so that's enough. I'm going to save it. Excel really hates people using other file formats, so I have to keep clicking over and over again to say, yes, I really do want it to be in the CSV format. And here it is, the updated file, and then we'll run the tool. Automated tagging. And here are the batches. So we did 5 items, and we're updating them. And then we processed a batch where there wasn't anything going on, but then here are 5 more items that are being updated. So it's going through and doing some work. And just to show that this is real interactive stuff, I'll run it a second time, and it should find, right, no work needs to be done anymore because everything has the right tag on it. Okay, so let's come back and we'll look at my library. So settings, site contents, documents. Here are my Contoso documents, and there's my tags that are filled in. So, and I did all of that, and we actually have 4 minutes left before the 15-minute Q&A period, so feel free to ask any questions that you want. Let me just put up the last slide here, because it has, let's see. This is what we talked about today, architecture, 3 demos, Q&A, and then this is the ECM blog. So it's probably, I think we're having some kind of MSDN downloads lockdown or something next week, so it may be a week or so before I actually put the code up there, but write down this URL. This is where you can go to get all the code that we looked at today. And if you're getting ready to walk out of the room, don't forget to do your evals. Okay. Do we have microphones so that we can hear the questions? Okay, you guys can just sort of line up behind the microphones. First question.
Okay, so for pulling in the metadata from something like SAP, for example, we're not going to necessarily have GUIDs generated for us. So what would your recommendation be for how we keep track of these terms?
Custom properties. You can put your key from the external system on a custom property. It's a string field. You can put whatever you want on there. And then if you're trying to synchronize or have other things to interact with SharePoint, they can find that other identifier in the custom property.
So you put a custom property on the term itself? Mm-hmm. Is that what you're saying?
Do you want to see, is everybody familiar with custom properties? I can show you what they look like if you want to see them. You want to see them? All right. Why not? So here's my term store manager. And here's our company divisions development. So let's say we got development from another system. I can go and add a custom property called something like other system ID, 1, 2, 3, or 5. And then in the OM, you can read this back in your tool when you're using it. Hopefully the server's still warmed up. Okay. And one other thing, just as long as we're looking at the screenshot, I should point out that there's 2 different kinds of custom properties because in the taxonomy, we have this idea of reused terms. So the same term can be a member of more than one term set. And it's kind of like a hard link in a Linux file system or something. But the idea is basically that this term appears in 2 different places. And if you rename it in one place, it will rename it in the other place. But we also allow you to store some properties that are different in each place. So for example, these custom properties will be, let me just do it. I'll just show you what it looks like. So I'm going to create another term like company divisions 2. And then I'm going to reuse the term from development. Did we deprecate it? Hold on. Let's try that again. Okay, reuse term. Development. Well, I'll try a different one. Engineering. There we go. Okay. So this term appears in 2 different term sets, and it has a different icon on it. And if you specify a custom property, so we're looking at engineering. So I'll specify this one here, ID 1, 2, 3. Then I go to the other place. I can see it here. But if I specified it down here, you can have different ones for each instance. And then there's also this feature called pinning that is just like reusing, except it brings the entire subtree. So it allows you to take a whole tree of things and have them mirrored. And if you create new ones or rename them, the entire tree will be synchronized. It's sort of like a persistent tree relationship rather than just a term relationship. So cool. Definitely can handle your question. Any other questions?
Just to clarify something, though, to be clear, as we're iterating through and doing moves, deletes, and things, we have to preserve those GUIDs once they're created one time, because I think those get tagged to the term when it's used in tagging, right?
Okay. So you want to talk about GUIDs some more? Yes, when you tag documents behind the scenes, it's actually the GUID. So if you, for example, went and renamed the term, it doesn't break the tag. It still remembers that it's tagged with that. And in fact, if you deleted the entire term set, it's not going to clear all your tags. If you go and look at the documents, they'll still have the tag, but basically the term doesn't exist anymore, and it's in sort of an odd state. Basically, the SharePoint object is a lookup item, so there's like this other list of data that sort of keeps a copy of the term data, with each SP web. And so if you then go and recreate the entire term set, as long as you keep the GUIDs the same, then everything will magically link up and it'll start working again. And this is also important for backup restore, because you might, for example, back up the taxonomies in a totally different SQL database, so you might back up and restore them in different sequences, so you don't want to lose that relationship. So the GUIDs are very important, and I encourage you in your tool to actually specify the GUIDs and keep them consistent.
Thanks.
Okay. Next.
I have one question. Your code, was that 2013 specific, or will it actually work on 2010?
I wrote it in 2010, and then I converted it to 2013, so it will definitely run in both.
Cool.
Oh, wait, do you mean SharePoint 2010 or Visual Studio?
I meant SharePoint 2010, yes.
Okay. So this code will mostly work in SharePoint 2010 except for the client OM stuff. So the server versions will, but SharePoint 2010 doesn't have the client OM. That's like a new feature in 2013. So if you're using 2010, you want to use the server version of the demos. And you might be wondering, well, how would I do any kind of client operations in 2010? Is it impossible? It is actually possible. It's just harder because you have to use these web services. Okay?
Okay, so the question is regarding the site collection term stores. So in 2010, the site collection, that one, the contorso.com, it's local to the site collection, but the API to create it is not open. So my question is does your, well, the specific scenario is that the term store that you are putting into the default is farm term store.
Can you ask it again? I didn't understand the question.
So instead of putting when you do the import, instead of putting the term sets into the default term store.
Oh, how would you put them in a different term store?
I would like to put it into the site collection term store, the one that you have
okay.
at contorso.com, and the API to create that was not open, in 2010.
Right,
so
but it is in 2013.
it is in 2010.
You can check to see if it exists, or you can create it if it doesn't already exist, and you can also access it from the client OM. So I was actually one of the people arguing that we really needed to fix that problem.
Exactly, because if you are doing that,
there was a way to do it in 2010. It just wasn't something that I would proudly recommend on stage.
Didn't work for us.
Pat, yes?
Actually, it was fixed in a QFE. So a little ways later, there is a public API on the term store. I think it's like get site collection term set, and or get site collection group, and it'll create it if it's not there and hand it back.
That's in 2010?
Pretty sure.
Okay. All right. I stand corrected. Pat's my manager, by the way, so no pressure today.
Just a more practical question. In a productive environment, how do I have to see it when those two systems run parallelly? Do you put that script on a daily basis, or are they somehow like talking?
So, you're asking if somebody actually coded this and made it into a production solution, how would they run it? Would they just run it from the DOS prompt every morning, before they get their coffee?
I mean, like more like, is it done on a daily base or hour base, or
Okay.
because now you put it on manually, the script.
Right. So if you're in an on-prem environment, the simplest thing would be to have it run as a timer job. And the taxonomy OM has a full event notification system, so you can query what are the recent changes in the taxonomy and which term sets have changed. We actually use this a lot in our own internal code. So you don't have to actually do everything over and over again. You can wait and detect when something has changed and then perform an incremental update.
Okay, thank you.
One thing to that, you really want to think about how often you want to do it, because just because the back-end system is changing doesn't mean you want to go change your taxonomy for your users regularly. Often there's an education process around what the taxonomy looks like. So it's really case-by-case businesses, right? The business needs to decide how often to run these scripts.
Is the pinning of navigation any different through the UI? Do you need to sort of mark something to then use it for navigation?
No. So basically, when we were working on navigation, I represented a very strong opinion that the navigation system should just be built on top of the normal taxonomy. It shouldn't be like a secret feature that does things in a really different way. So I'm actually very passionate about the answer to this question. But the pinning feature was introduced as a primitive, central feature of the taxonomy. So you can use pinning for other purposes besides managed navigation. And the way that managed navigation uses it is as a regular consumer, and the navigation data is actually just stored in custom properties. We do have a way of hiding the custom properties so they don't show up in the UI, so people don't edit them and mess it up by accident. But pinning is exactly the same OM that you see here. And there is a managed navigation API that sort of sits on top of that, and it provides a way of doing all the operations in a more natural way for managed navigation, but you could also do the same operations just by working on the lower level taxonomy representation.
Okay, so in 2010 you'd normally have like a navigation provider. Is it in your master page or whatever, you're sort of effectively binding it to a terms store or to render the navigation?
So if you want to get into managed navigation, there is a sitemap provider. So in 2010, it's like Portal sitemap provider that drives the menus. So in 2013, we introduced a taxonomy sitemap provider, and that's kind of the magic thing that connects to the term store. But it's not like every time you load a page, it's going to go to the term store and read the terms and term sets. It has a very elaborate and sophisticated caching system that some Microsoft employee made that makes it really efficient. Yeah, it was me. Yeah.
Okay, is all this nice code you have provided, are there plans to put this into the product? And
well, we can't really answer questions about future releases of SharePoint. So I don't know.
Not decided, yeah. The other question is, you mentioned briefly term sets or term store limitations. Do you have any recommendations if you have really a large number of terms exceeding the current limitations of 30K per term set or a million in the term
Could you talk a little louder? I'm having trouble.
Oh, sorry. You mentioned the limitations of the term store. 30K terms in a term set and a million terms in the term store. Mm-hmm. Have you any recommendations if you have more terms?
Right. So if you have more terms than, say, 1 million terms in your term store, you might first think about what you're really using the terms for. Like perhaps you're not really using the taxonomy in an appropriate way. If you did actually have like a really huge number of categories, you could split them across multiple term stores. That would be one solution. You could do something that's not supported by Microsoft and just have really fast hardware. I don't know, probably won't work.
Really, what you want to do, I think, Pete's first answer, think about the taxonomy of 1 million.
Like nobody in this room said that they had that when I asked the question.
Imagine that you had that, you probably just want to split it into 2 taxonomy services and have one part of your business using one, the other using the other. Because having a tree of 1 million terms, there's no user that will be able to navigate that tree anyway.
Yeah, what would the term store manager look like in that case? I mean,
Well, we have
that's a lot of categories of things. Like I could certainly imagine if you created a term for every single data object, but that's not really a common.
For us, it's about compounds, and we have 3 million of compounds. Yeah, and
what are they?
It's chemical compounds we have and we want to use for tagging. And this cannot be split by business departments because the different departments use the compounds across the field.
Then you should talk to Dan after this session, because I bet he could have some interesting propositions for you.
Okay.
Yeah.
Thank you. Yeah.
That sounds interesting.
I have a question about searching in the refinement panel. Is there a way to surface the hierarchy into the refinement panel so I can search by a level 1 term and get results for the level 2 terms or lower?
Let's talk about that separately. That's not really a taxonomy question.
Okay.
I'll be at Ask the Experts also. Anybody else? We got 4 minutes left.
So my question is with regards to managed navigation.
Okay.
So can you have one global term set and have 2 different site collections share that global navigation term set?
So in an earlier design, we did allow that. The problem was that when people create stuff, when people are working on one site collection and they create it or change it, it has unforeseen effects on the other one. And in particular, the navigation terms tend to point to objects in the site collection. So when you're on the other one, you have to sort of track stuff differently. So pinning is the solution that we came up with to allow you to have the same hierarchy sort of appear in different navigation systems, but sort of keep it structured so that people really understand, this is the central location of where you edit it, and then these are the different representations of it.
It just requires to create that pin each time you create a new site collection.
Sorry?
It requires you to create that pin each time you create a new site collection. And if you wanted to do like a global nav solution.
So there is a scenario where you just want to have a small set of links that, say, appear on every single site that you have, and it's more or less static. But in that case, you could put it in the master page, or maybe like the whole value of managed navigation is that it lets people edit stuff, easily. They can edit it in the term store manager, or they can sync it with other systems and stuff. Whereas something that is like that probably doesn't. It's not something that you want to be changing dynamically. It's more like some central person designs it and then pushes it out.
Okay.
I mean, I'm not saying that wouldn't be an interesting feature to build, but it's. Yeah, we did. Right.
In 2010, I've found deploying, say, content types where you've got field references.
Can you talk?
Sorry, in 2010, like if you're developing, say, a content type and you've got field references to manage metadata services, do you think it's sort of better to sort of utilise a utility like that as a precursor to the deployment of that content type, or should you still, inside your solution, try and do the binding? I've found that there's sometimes a timing issue in 2010 where it sort of doesn't quite get the binding. You have to go back in to the UI and reattach content types to the managed metadata service or to the term set.
Yeah, it might be useful to use a tool for that. So the tool will just sort of populate it. For our own testing internally, I have another tool I made that is kind of this idea, but it's more structured. And I'm actually probably going to release that very soon also. I really wanted to have it up by the conference, but I got into this other project of trying to release these code samples because they're the code that we talked about. But we internally use this tool, and for our testing and stuff, we will spin up a whole site collection from an XML file, basically. And you can do incremental updates and stuff like that. So. Yes.
Yes, I would like to come back to the limit of 1,000 term sets per term store. What we noticed is that when we're activating some wiki features on the site collection, it creates automatically a wiki categories term set. So that if you have 1,000 site collection, you already have behind the scenes 1,000 term set created. So what about this limits of 1,000 term set per term store?
Is it 1,000 per term store or per group?
So I think it's, but those are global ones. The site collection scope ones don't count into that that total. The main limit on that one is just that the UI becomes more or less unusable. So.
It's not a hard.
Yeah.
Like it's SQL underneath, right? It'll just store. To be perfectly honest, we had concerns around the term store tool. How do we represent all this stuff in a tree?
Oh, yeah.
It starts getting crazy big. And frankly, most users, like I was saying earlier, there are very few scenarios
Mhm. Yeah, yeah, that's the same problem, yeah. Okay, thank you.
Okay, 10 seconds. Last question. All right, well, thank you very much for coming.